Okay, so like I said, we were planning on taking our test tomorrow, but they're doing ACT at the school here tomorrow, and they're needing all the calculators, so that's just not going to work. So I did change that on the board there, so the test will actually be on Wednesday. So what we're going to do today is this. We're just going to practice the same stuff we did on Thursday and Friday, just to reinforce that. Tomorrow you'll have just like the formal test review, and then Wednesday you'll be taking the test. Okay, so let's jump in here. So on this one, for angle 1, what do we have to do to find angle 1 there?
Add 40 and 50 and divide by 2.
Okay, good. So we have these two secants meeting somewhere inside the circle. You add, divide by 2. It's just the average of that, or just, halfway between those. So what's halfway between 40 and 52? Or 40 plus 52 divided by 2 is what?
46.
It's 46 degrees. Okay, number 2. Now this one's not asking for the angle. We know the angle is 45. It's looking for arc GH. So there's two different ways to do this. You could just say, okay, how far is it from 28 to 45? And it's going to be that same distance from that angle to that arc. Or you could say, if this is x degrees, you could say 28 plus x divided by 2 equals 45. This arc FE, which is 28, plus arc GH, which we don't know, that's what we're looking for is x, divided by 2 gives you that angle of 45. Okay, so what do we have to do to solve for x here? Multiply by 2 on both sides. That way on the left side, the 2 times 2, that cancels to 1. And then on the right-hand side, if I multiply by 2, I get 90. Subtract 28 from both sides. 70, 62. So does 28 plus 62 divided by 2 give you 45? And the answer is yes, it does. Okay, on this one. Okay, so here the angles are in the circle. When the angles are in the circle somewhere, you add, divide by 2. Here the angle is on the circle. We're looking for angle 3. So the arc is 220. So how do we find that angle from that arc? Just divide it by 2. Okay, you don't have to add or subtract. You just divide that arc by 2, which means angle 3 is what? 110 degrees. Just half of that 220 degree arc. Okay, number 4. How big is arc RT?
148.
It's 148. It's just double the angle. Okay, on this one, so we can't find angle 5 to start off with. We've got to find this angle right here. So 130 plus 90 divided by 2 is going to be 110. Good. Then these two are linear pair. The angle I just found in 5, so that means, yep, angle 5 is 70 degrees. Okay, on this one, so the arc on this side is 160. So how big?
360.
Good. So this arc over here has to be what?
200.
200, because in a full circle is how many degrees?
360.
360. So on this side, that arc is 200. So how big is angle 6 there? It's half of that. It's just 100 degrees. 100. 100. Okay. Now here, the angle is on the outside of the circle. So what do we do when the angle's on the outside? You subtract and divide by 2. Bless you. So you take this arc 80 minus this arc 40 divided by 2 to give you that angle. And so 80 minus 40 is 40 divided by 2 is 20. Okay, on this one to find angle 2, it's 160 minus 80 divided by 2.
80. 40.
So it's 40. Yep. Okay, on this one, All right. Problem on this one is I don't know how many degrees it is from here to here. And I don't know how many degrees it is from here to here. Okay, so I don't know how many degrees this side is. So I'm just going to say the major arc LN is X degrees.
X, is it X plus Y or X minus Y? No, equals 50.
Okay, yeah, so we'll get to that in a second. Let's do the thing that we know for sure first. So forget about the 50. Whenever I put that arc, the major arc, and the minor arc together, how many degrees is that? 360. So if I take X and I add Y to it, what do they add up to? 360. So that's one fact that I know within this problem, within this system. That's one for sure fact. Now there's another fact that I know related to what we talked about here. Okay.
X minus Y divided by 2 equals 50.
Good. And that's the other thing that I know. If I take X and I subtract Y and I divide by 2, that's going to give me that angle, which is 50 degrees here. So within the same system, within the same problem, there's two independent facts that I know. I know that X plus Y is 360, and I know X minus Y divided by 2 equals 50. So I've got a system of equations here. So again, there's a bunch of ways to do this. The way we're going to do it is just to plug it into our calculators and let it do it for us. So plug that into menu 3.2 real quick. Do the lens solve. So menu 3.2, two equations, X and Y. So we have that if you take X plus Y, that equals 360 degrees. And I also know that X minus Y divided by 2 equals, it's 50. So that tells you right there. The major arc is 230 degrees. The minor arc is 130. Because watch this. If I take that 230 and I add the 130, when I add those two arcs up, what do I get? 360. So that's true. That's good. Then also, if I take the major arc 230 minus 130 divided by 2, so X minus Y divided by 2, yep, right there, boom, gives me that angle of 50 degrees. So the major arc is 230. The minor arc is 130. All right. And this is asking for LN, which is the minor arc. So how many degrees is that?
130.
It's 130 degrees. This one over here is 230. This one's 130. All right. Then on this one, okay, so it's 110 from here to here, it's 100 from here to here, and it's 80 from here to here. So how am I going to find this last little piece right here? Add them all, take that from 360, or just do 360 minus all those, and what does that leave you for that MP?
290.
Gives you 70. So you're just going to do 100 minus 70 divided by 2.
So it's 15.
So it's 15 degrees. Yep. That's fine. The difference between these is that this on Thursday was talking about the measurement of angles and arcs. All right, so that was like the stuff we did on Thursday. Here on the back is like what we did on Friday. And this from what we did on Friday is talking about the length of segments. Okay? So like all the stuff we just did was, the answers was degrees basically. Here, the answer is lengths. Okay, so let's see if you remember the relationship. So this piece is 2 from here to here, and it's X from here to here. And then it's 3 from here to here, and 6 from here to here. Good. Yep, so 2 times X, equals 3 times 6. 2 times x equals 3 times 6. So, so x should equal 9. 2 times 9 is 18. 3 times 6 is 18. Yep.
Is there a way to like see if it's true?
Yeah, I mean, just type in 2 times 9 equal to 3 times 6.
Oh, okay. Well, I thought you did something. No, like last week.
That's exactly what we did.
Well, it's just because this one's so easy that I mean, it's just that easy. It's the same thing. It's just there was a lot more x's involved last week, which we're going to get to that in a second. Okay. So on this one, all right, from here to here is 10. The radius is 10. So if this is 2 from here to here, then good. From here to here is going to be 8. All right, so this piece from here to here is 2. How long is this piece all the way from here to here? It's 18. So there's a little piece that's 2. Yep. And then from here to here is 18. Right? So 2 times 18 equals x times x. Two times 18 equals x times x. So 36 equals x squared. How do we get rid of a squared?
The square root.
Square root, which means x equals 6. And that makes sense. 2 times 18 is 36. 6 times 6 is 36. All right. On this one, 6 times x equals 8 times 8. 6x equals 64. Divide by 6. That's 10 and 4, 6. 10 and 2/3, 10.67.
You already know these, or you want to do it in your head?
That one I can do in my head because...
You did
Okay, on this one, x times x plus 7 equals 3 times 6.
So x squared plus 7x equals 18.
Okay, is the x squared going to be able to be canceled out here in any way? No.
Bring your 18 over.
Okay, so I'm going to bring the 18 over by subtracting 18 from both sides. And as always, there's a lot of ways to do this, but easiest way for me on this is just to graph it. So let's plug that in our calculator.
Oh, I can't see that.
What was it again? X squared plus 7x minus 18. Yeah. All right. So where does it cross the x at?
2.
At 2 and at negative 10, but again, within this context, the negative 10 doesn't make sense. It's the 2 that matters. Okay? So x equals 2. Thank you. Alrighty. So x equals 2. Then you could type in, I mean not type in, but just plug in 2 and see if that makes sense. So if this is 2, if x is 2, then that's 2, then how long is this piece down here? How long is this piece down here if x is 2? 9. Okay, what is 3 times 6?
18.
18. What's 2 times 9? 18. So that looks good. That's what he's talking about. Yep. Okay. All right, dropping down to the bottom down here. Okay. So this piece right here, is this a secant or a tangent?
Secant, no.
That piece that I just drew in red, is that a secant or a tangent?
A tangent.
Tangent.
It looks like a tangent, right?
But actually,
No, it's a tangent. We're going to go with that. Okay, so if you remember, I told you this on Friday. So here's the deal. The tangent piece squared equals the whole times the outside. Tangent piece squared equals the whole times the outside. So in this case, the tangent piece is 3.3. So we have 3.3 squared equals... Okay, how long is this whole thing TP?
Plus X.
Okay, good. 2.2 plus X.
Times 2.2.
Okay. Times, how long is the outside piece of that segment?
2.2.
2.2. Okay, so 3.3 squared is 10.89. 2.2 times 2.2 is 4.84, I think.
Times 2.2x.
Oh my god.
Or plus 2.2x.
Yep. So all we're doing there is just distributing. I mean, just doing simple algebra stuff here. Okay, so subtract 4.84. So that's going to give you 6.05 equals 2.2x divided by 2.2.
This is a lot of points.
Yep.
2.75.
2.75.
Exactly what I just said.
Okay, then on this one we have two secants. And so on this one, this is whole times outside equals the whole piece times the outside.
This will be 42
Okay, good. So the whole thing TR is 42
times 16
times the outside piece of 16.
18 plus X times 18. 672 equals. Dude, I'm on a road today. Equals 324 times 18. Or plus 18.
Okay. So subtract 324.
I need a bigger paper.
672. 324 is 348. Divided by 18.